Here are some applications we can do. For example, what is the deadline for Milwaukee General Hospital? It is 16 weeks. It is given by the environmental agency. So it is the deadline. And question is, what is the chance that this project can be finished on or before the deadline? So here's the formula you can use for this kind of situation. We calculate the z-value. Z-value is a normal score. So due date minus expected completion date divided by standard deviation. In this example, due date is 16 weeks. So we plug in due date 16 weeks here. Expected completion time from our calculation result in the last slide is 15 weeks. The expected time for on the critical path. So 16 minus 15 weeks divided by standard deviation. We know from our last calculations 1.76. So we got the z-score is 0.57. Using the normal distribution table, we find 0.57 in the first column and the first row. So 0.57 is 0.5 and a 7 here. The reading in the body of the table is the row of 0.05 and the column of 0.07. It is 0.7157. Okay, so the probability here is 71.57%, which is corresponding to the z-value on the axis. On the horizontal axis, 0.57. This one tells us that there's a 71.57% of the chance that the project can be put in place in 16 weeks. So this is a good estimation after rigorous analysis. And the managerial impacts here is that the hospital can do the estimation based on such a rigorous analysis and answer these environmental agency that even though the 16 weeks is given to them, what they can complete, the chance they can complete it within 16 weeks is 71.57%. Based on this relatively rigorous analysis, the hospital can negotiate with the agency and then maybe get more time for the project. Another application. What is the date that a Milwaukee hospital can finish the project with 99% sure? So the formula is as following. Date equals to expected completion time plus z of 0.99 times standard deviation. Z.99 is the normal score corresponding to probability 0.99. It is 2.33. So we apply the formula here. Expected completion time is 15 weeks as we estimated. Z-score is 2.33. Standard deviation as we calculated is 1.76. So the result is 19.1 weeks. Here comes the conclusion. If the hospital need to be 99% sure, then the project can be finished, in other words, needs 19.1 weeks. They need 19.1 weeks at least to finish this project with 99% sure. This is also we call that a confidence level, if you would like to use the statistical terms. This is another good example. For example, the managerial impacts is the environmental agency asked the Milwaukee Hospital, we want you to be, what is the latest time you can be almost sure that you can finish it? And the answer is 19.1 weeks. And this is not come from nowhere. This comes from rigorous analysis. So it's those kind of analysis-based negotiation usually is much easier for both parties to work on. There are some advantages and disadvantages of this PERT or CPM technique. The advantages are it is straightforward and it's visually easy for us to use, and then there's a unique strength when we manage a complex project. And it pinpoints the activities on this critical path that need to be closely watched. And it can provide quantitative results to facilitate planning, communication, and negotiation. Some caveats, downside of it, is that we need to clearly define activities and the relationships among activities. And a lot of times we have to assume the distribution of the activity times. So this is something good or bad, we make assumption, we say it is better distribution. It's better than we don't have any assumption, but again, we locked into this better distribution, so we don't know how well it works. In general, it works well, so that's probably what we should remember. There is a exercise available for you to work on. The answer key is also provided. Also, thank you very much.